It'll be easier, I think, to understand this if we start in this weird ancient program that I have, because visualizing what's going to happen with these new volumes is a little tricky. So we've done volumes by revolution. Take a shape, whether it's a pretty shape like a rectangle or a weird shape, and spin it around an axis. X-axis, Y-axis, Y equals 3, X equals -2, whatever. This is something completely different. This is called using a cross-section to generate an area. So we need two things. We need to know what shape is the base. In this first picture that I'm going to show you, the base is a circle. And then we need to decide what we're going to stack up on top of that base. The most common shapes we'll use will be squares, equilateral triangles, isosceles triangles, semicircles. Okay. So I'm going to show you, go through a couple of these and show you what they look like, and then we'll get into the slideshow which shows you how to do it. Okay, so first things first, we're going to turn this into kind of a 3D looking thing here so that you can visualize the model. Okay, what I'm going to do is I'm going to take this circle and I'm going to stack squares on top of it. Those squares are going to be perpendicular to the x-axis. So, for instance, they would look something like that. Okay. Now, you'll notice what happens to the squares as I get farther and farther away from the center. The biggest square is that light pink one, and that's when it's actually the base of the square is the diameter of the circle. As I move to the right, you see that those squares get smaller until eventually when I go all the way out to R, the square will shrink down to 0. The same is true going the other way. So I did this first, going in this direction, but I could also do going back the other way. So the question I have for you is, can you visualize in your mind what that final three-dimensional object is going to look like? I'll give you 5 seconds. This is freaking me out. Okay. That's fine.
Maeve is missing.
Okay. Where is she? I saw her earlier. Did she?
She's she stays showcasing her.
She did.
Class trip done well.
So that's what happens to the square. When we start on the far, when we start on the far right side, also known as negative radius, we start with an infinitely small square, and then as it slides on, gets at that point, and it's the biggest square possible, and then shrinks and shrinks and shrinks and shrinks down to 0, and then starts over again. When you put all those together, we get that thing. Okay? So it looks like that. Now, I've got good news and I've got bad news. Which would you like first? Bad news, you're going to have to find the volume of that. The good news is you're not going to have to draw it. But if you look at that model for a second, what can you tell me about this curved edge and that back curved edge? What shape is that? It's a cylinder, correct. That's actually a cylinder that we shaved off the top. And there's no shaving, it's actually stacking. So this is what's called a volume by cross sections. Okay, so what can we change? We can change one of the two things. We either change the shape of the base, or we change the shape of the thing stacked up on top. So if I come over here, same idea, same base. I'm taking a circle, put it at the origin with a radius of R, and in this case I'm going to stack equilateral triangles on top. So you look like that. So it looks like that. Okay, take 5 seconds and see if you can visualize what that looks like when I have it draw the picture. Got it? So that one equilateral triangle is going to follow the same pattern as the square. There's the biggest one right there, and then it shrinks down to 0 again. And when you see it all put together, you get that thing. No cylinder involved here. So again, we're going to talk about how to find the volume of that thing. Okay, what else can we change? Let's use a right triangle as a base. Oops, get over there. Oh, I just broke it. Close enough. We'll use a right triangle as a base, and we'll stack on top of that right triangle semicircles. Hopefully this will fit in the screen. Ooh, that's a little. Hold, please. Let's try that. That might be better. Okay, so 5 semicircles stacked on top of that. If you sweep them, you get that. This one's pretty easy because when you create it, you get a cone, half of a cone. Not a cone. Got it? Some of the problems you're not going to be able to visualize what the shape looks like. That's okay, because I'm going to show you the math associated with that. Any questions so far? Need to see anything else on this before I leave it? Okay, good. So then let's go to the slideshow and look at how to do the math here. Did I post this slideshow, by the way? Yeah. All right, good. Okay. Today, we are going to find the volumes using cross sections, and of course, you should be able to enjoy spicy food. If you already do, try spicier food. If you don't, live on the edge. You like spicy food?
I'm okay with
Just okay?
it. Yeah, I mean, I like it, but I'll be fine.
I understand. I understand it happens. You can work through that thing.
Yeah.
Great, beautiful. Okay, so cross sections, we did that already. Accumulate, yeah, great. Rectangles, squares, triangles, semicircle. Ooh, trapezoids sometimes too. I forgot that one. Whoa. Stack a trapezoid on top of that bad boy. It's going to be fun. Don't you shake your head, Bryce. Shake it the other way. That'll be great on the video. Okay. So this is just a graphic. The same ideas that we talked about before are going to be true. You're going to have a representative rectangle. And in fact, we're not going to use a representative rectangle. We're going to use a representative cross section. And I'll show you what that looks like. The nice thing is, all you need to do is find the area of a cross section. And then you just integrate. So in these previous problems we did, all you need to do is find the area of the square. Integrate, done. Find the area of the equilateral triangle, done. Find the area of the isosceles triangle. Find the area of the trapezoid. Whatever it is you're stacking up on top, find the area of one of them and we're good to go. Any problems so far? All right, let's dive into it. We'll start with an easy one. Now the reason this one is easy is because I'm stacking a rectangle on top of a parabola. So therefore, unlike the examples I showed you, the rectangle size, sorry, let me rephrase that. The height of the rectangle will not change. Okay, so notice when I did an equilateral triangle, when I did an equilateral triangle or a square, the size changed because it was bound to that bottom that was sitting on the circle. This is not the case. I decided to do the first one easily with fixing the height at being 2. What's going to change is the base. Okay, so before we get started, draw a picture of what the base looks like. In other words, graph x equals y squared and the line x equals 9 to make sure we're all on the same page. This could be a little tricky for some of you because you can't put that into a calculator to have it graph for you. You have to know what the graph of x equals y squared looks like. Quick reminder, it's x equals y squared, not y equals x squared. It's not a U-shaped parabola. Like a lot of things, don't forget the x equals 9 because we have to have a bounded region. Well done. Great. Still getting there. Nice. Working on it. Almost. No. Yep. Good. Don't forget x equals 9. Love it. Love it. Okay. Shade the region we're going to use as a base, please. you'll see in the problem that it says we're taking a cross section that's perpendicular to the x-axis. So in that bounded region, in a different color, because you're all on iPads, draw a representative rectangle. You said we're using a representative cross section. Just do it.
Isn't it like y is squared left? Yeah.
But you gotta do plus or minus, so it's the top curve and the bottom curve. Notice that. Okay, so a couple people walking around the room, a couple people just had the top part of that bounded region shaded. It doesn't say anything about the x-axis in there as far as the region goes. It's purely the region bounded by the graph of x equals y squared and the line x equals 9. So it should be a parabola shaped sideways, well here, it looks like that. Okay. Now, I put my representative rectangle all the way to the right-hand side. You could put it anywhere. What you should be visualizing is where this big fat segment is, I'm going to have a rectangle sticking out of the board. And then that just popped up because I got too close to the board. Okay?
How do you know when the representative rectangle is horizontal or vertical?
It tells you perpendicular to the x-axis. Yeah. Because we could do the same problem but make it the other way.
Yeah.
We're not going to because it's ugly. Depending on where you drew your representative rectangle, you're not going to find the length of that rectangle or the height of that rectangle in terms of a numerical value. You're going to do it in terms of a function. So you'll notice I'm going through the same process I talked about with revolutions. My representative rectangle is vertical. Since it's vertical, I'm going to be working in terms of x. So I started by solving that function for for y. Took the square root of both sides. Quick side note here. We've talked about this before, but we'll mention it again. What's the difference between this and that?
Plus or minus?
Explain.
If you take the root of the one on the left, it's plus or minus x.
Well done. If I solve this for y, I'm going to get y equals plus or minus the square root of x. This, on the left, is the graph of what I've got over here on the right. This is what you're used to with just being this curvy part, is what you normally work with. We want the whole thing. Okay? Good. Little sidebar done. Let's get rid of that and start over. I chose my representative rectangle to be here. I need to calculate that distance, and obviously it's in my picture already, so you realize that. But what I did is if I pick a random point on that curve, it's going to have the coordinates x comma f of x, which in this case is x comma square root of x, which makes that distance 2 square roots of x. Everybody with me? Okay, good. That's the hardest part of these problems in my humble opinion. Okay, now, there's nothing in that picture that explains what shape I'm stacking on top of that section. So over on the left, I draw a picture. Yours doesn't have to be so fancy, but it gets the job done. It's a rectangle, and you'll notice that the big black segment in the parabola-looking picture matches the big black segment in the rectangle picture, because it's stacked up on top. Okay? We've done all the hard stuff. Now the easy stuff. What's the area of that rectangle? 4 square root of x. And we're taking rectangles from where to where? 0 to
X.
to 9. 0 to 9. Done. Bingo. That's it. Okay, now, I'm making it sound a little bit easier than it is. There's a lot of work that went into that. You're going to struggle most common mistake, or not even mistake, the biggest struggle is figuring out where that point is. But again, remember that's x comma f of x. If we're dealing with things in terms of y, then it's f of y comma y. And you will see problems where it's perpendicular to the y-axis, which means it's horizontal, which means you work in terms of y. Okay, so let me stop for a second. Questions, Mia?
Can you say where the 2 comes from again?
Beautiful. Okay, so if I was getting to this red point, I would come along this distance, x. I would go up that distance by the square root of x. I want this whole distance, so it's going to be that plus that, so it doubles.
But where like the length is it too? On the rectangle?
Oh, because it says so in the problem.
Oh.
Yeah, I fixed the height of the rectangle to be 2. Okay, hold on one second, Chris. Now, if you're feeling fancies in your pantsies, you could just do the square root of x and put a 2 out in front here, because if I do half of this, it matches the bottom half, but it's up to you. Chris, question?
Well, can you explain your sidebar again with x equals y squared?
Yeah. If I ask you to graph this, okay, we know that's a function. We use it all the time, right? That is this.
Yeah.
Okay. However, this is not a function. Because if I try to graph this, I'm going to solve for y by taking the square root of both sides. And when I take the square root of both sides, I need the plus or minus. The plus is the top part, which we're used to. The minus is the bottom part, which gives me this guy down here. Okay? Questions? We're good. Okay, so I'm going to change one thing in the problem. I'm going to get rid of all this writing. And I'm going to click backwards. And we're going to do the same. Go ahead.
Okay.
I'm going to do the same problem, but we're going to stack something different on top of it. And Jacqueline's going to be kind enough to decide what we're going to stack on top. Your choices are A, a square, B, an isosceles, or sorry, an equilateral triangle, or C, a semicircle. Any one of those three is acceptable. A semicircle, outstanding. I'm going to do the exact same problem, but instead of a rectangle, it's going to be a semicircle, which means I'm going to start with this. It's not great. What's the radius of that semicircle? Patrick? No. Good, root x. Okay. So the radius from here to here is the radius, which is the square root of x. Okay. Everybody good with that? Yes? Okay, Tori, what's the area of that semicircle then, based on what Patrick just did?
1/2 pi r squared.
You good with that? Tori, yes?
Yes.
Okay, good. Which would be pi over 2 times x. Okay, that's the hard part. We're done. What's the volume? Well, we're not done. The volume of that thing would then be pi over 2. It's a constant. I'm going to move it out in front. Still going from 0 to 9 of x dx. If Jacqueline would have chosen a square, we would do 2x, 2 square roots of x quantity squared. If she had chosen an equilateral triangle, we're going to wait for the next slide. I'm glad you didn't pick that because I got that on the next slide. Okay, any questions before I move on? This process is just going to continue. The only thing that's going to change is the shape of the base, the shape of the cross sections, and whether you're working perpendicular to the x-axis or perpendicular to the y-axis. Okay, I can move on? Beautiful. So now we'll bring a circle in. We'll do one of the problems we saw on the sketch pad thing. I'm gonna have a base with a radius of 4. In the example that I showed you in Sketchpad, the radius was r. We'll make it easier and make it a radius of 4. And then we're gonna stack equilateral triangles perpendicular to the y-axis. So we'll start with that. To make my life easy, I'm gonna put it centered around the origin with a radius of 4. Allison, what's the equation of that circle? Oh, there's two action going on here.
Sorry, I'm thinking about a semicircle. You said the equation for the area?
No, just the equation of that circle itself. What's the formula for a circle? Not formula, the equation of a circle.
What's the area of the circle?
No,
Or
just-
the circumference of the circle?
No, imagine that circle is on a coordinate plane.
Oh.
Anybody? Are you raising your hand, or, yeah, go ahead, take a shot at it. Worst thing that happen is you're wrong and we all point and laugh at you. You know I was kidding. I wouldn't point and laugh at you. I wouldn't point. Or if I did, I'd like to use my elbow to point, because this is rude.
Oh, okay. Is it 16 minus X?
No, that's a semicircle.
Oh.
Anybody else? Go.
Isn't there like an x squared and a y squared in there? And there's like.
And there's a
add all
16
these-
in there. Now throw that in the witch's cauldron, stir that up.
Why is there a 16?
X squared plus y squared plus
Say again?
r squared.
And what's r?
The radius are 4.
4. So therefore the equation of that circle is?
X squared plus y squared equals 16.
Good. Gesundheit. Is that you? Yeah, Gesundheit. Okay, good. X squared plus y squared equals 16. By the way, just as a reminder, the equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. Yeah?
The junior should know this. This is on the SAT.
You tell them, Chris.
Would
Good.
you like write that down real quick?
Certainly.
No, you don't.
Oh, bad color.
I mean, you can like still have microcolleges. Yeah, I'm gonna take it now.
Little blast from the past. I put the circle on the origin, so h and k are obviously 0. We know the radius is 4. We're good to go. Okay. Giselle, am I going to work in x's or y's? Holding.
Like, I get to pick, or?
No. That would be a, I'm looking for the correct answer. I don't give you the flexibility that Jacqueline has.
Wait. Why? Right? No, that's.
No, I almost made a joke about why, because we have to solve the problem, but, so your answer is y.
Yeah,
Are you sure?
not really, no.
Maria, what do you think? You're supposed to be watching out for her,
Why?
because it's her job.
No,
Yes, it's in terms of y. How do we know it's in terms of y? Perpendicular to the y-axis, which is irrelevant. What's important is that it's horizontal. Same rules apply. If my representative rectangle, which is down there, is horizontal, everything's in terms of y. Okay, so if we start with that, question in the back.
Why is the couldn't the rectangle be vertical? Why is it horizontal?
It could, except in this particular problem, I want it to be perpendicular to the y-axis. Because it's a circle, you could easily move it perpendicular to the x-axis, you'd get the same answer. I'm just choosing to do this one this way for 2 reasons. Number one, it'll practice doing it in terms of y, and we're introducing equilateral triangles. Okay. All right, so we're in terms of y. Solve that equation for x, please. Now that you've done that, I highlighted a point on that circle. It's just any random point, it doesn't matter. What's the coordinate, what are the coordinates of that rando point? I'll give you half of it. Ready? All right. Excellent. What's the x value?
Positive or negative 4.
No. That would be true if I chose this point, but I'm picking any rando point. Anybody else?
Positive negative x.
No? Well, yes, kind of.
Square root of 16 minus y squared.
Square root of 16 minus y squared. Why? Go.
Because I solved for x and y squared plus, sorry, x squared plus y squared equals 16.
Good. Now, you might be saying to yourself, well, shouldn't it be plus or minus? It doesn't matter. It's any point. I could make it negative, but to make my life easier, I'm going to make it positive. Okay. We're getting there. How long is that? Say it loud, say it loud, Patrick. Lovely. 2 times the square root of 16 minus y squared. Excellent. Okay, now we move on to the equilateral triangle. At this point, I don't care what shape I put on top of that. I could go back to Jacqueline and ask her again for all the possibilities. Equilateral triangle, rectangle, square, semicircle, isosceles triangle with that being the hypotenuse, isosceles triangle with that being the base, whatever you want to do. We're going to do equilateral triangle. So we got that. I don't want to click it. What do you got on your screen? You got a blank screen. Okay, good. For those of you that had good geometry teachers, do you remember the way to find the area of an equilateral triangle that's not 1/2 base times height?
Like if you combine a bunch of like
So you would use
I have
a
to do
formula
that
to find
one.
the area of a hexagon
right.
algebraically, then divide that answer by
I'm
6.
just shooting ideas.
You know, that's not a wrong answer. That is correct. It's just be a lot of algebra. Yeah. I'll save you the hassles and I'll just tell you what it is. That's what Patrick told us. Okay, so there's our equilateral triangle now because I need to include my picture there. We could do 1/2 base times height. Right, so you do Pythagorean theorem, or you do 30, 60, 90 triangles and find the dashed segment. You got the base, you got the height, whatever. But I will remind you that the area of an equilateral triangle is s squared square root of 3/4, where s is the side of the triangle. And for some of you, the memories are just flooding back into you right now. You remember those wonderful days we spent deriving that formula. Do you see where to proceed from here? What's S? Correct. What? That was my fault. In this particular problem, what is the value of S?
2 square root of 16 minus 1 square.
Beautiful. Plug und chug. There's the area of that triangle. One last question. We're taking triangles from where to where? -4 to 4. Beautiful. If you're feeling saucy, however, you could go from 0 to 4 and double your answer. Find half of the volume of half of the shape and then double it. It's up to you. Sometimes I like to do that because, as we've talked about in the past, plugging in 0 is frequently a lot easier than plugging in -4. Okay, so we get, ba-bum, that. Now, that was a big jump, let me back up. So I got the area, since I'm squaring 2 square roots of 16 minus y squared, 2 squared is 4, cancels with the 4. The square of a square root cancels also, so I get the square root of 3 times the quantity, 16 minus y squared. You could distribute the square root of 3, but that would be silly. I'm just going to move it out in front and get to this. If I remember correctly, I think I solved the rest of the problem. Yeah, I did, but it's irrelevant. We don't, that's not really what I care about. It's because you'll be able to do that. It's getting to that point that's going to be difficult. Oops. Question in the back.
Will we be having calculators on this?
This particular problem is one that I would give you either way. Those numbers aren't unmanageable. They're not fun, but they're not unmanageable.
Okay, then like if we got all of the work up until the answer part, right? Would that just be like 1 point off because we got the answer wrong?
Depends on how I set up the grading, but yeah, it's not, a lot of the question, when I'm coming up with a point value, a lot of the question I ask myself is what am I testing here? Am I testing that you can add 64 and 64 thirds, or am I testing if you can set up the calculus? So to answer your question, probably a point, 2 points maybe, depending on how ugly the math is. Mia, you got a question?
Yeah, can you repeat why the square root of 3 is integrated?
Because it's a constant, so you could move it out in front.
Oh.
Okay, so for instance, if I'm doing the integral of 2x dx, that's the same thing as 2 times the integral of x dx. Okay, you leave it in there or take it out, it doesn't matter. In this case, I don't want to work with square roots of 3, so I move it out in front. Okay, how we doing? This is not a huge topic. It's not like you're going to see 8 problems on the AP test. But this is a problem that's always, from my experience, attached to a revolution problem. And you'll see when we start looking at actual AP questions. A normal AP question with this is based off of a revolution. So they'll give you an area of a region. They'll ask you to find the area of that region. Then they'll ask you to revolve that region and find a volume. Then they'll ask you to find the cross-sectional volume of that region with something stacked on top of it. Usually travel in 3 parts. All good? It's not a joke, it's just a speed lunch. Right?
I guess we're done.
That's just it's a cross-section of the Millennium Falcon. Yeah. Right. A little movie called Star Wars, you ever heard of it?
We have to watch.
Yeah,
right now.
The list of movies we have to watch is getting bigger and bigger every day. What are some of the other ones we haven't seen? Because no matter what movie is mentioned, Patrick yells out, "We have to watch it!"
We had to watch the World Cup when it was playing.
Where's that 50?
Cool.
Did watch
Okay.
all day.